Assalamu alaikum, Miram. How are you?
Walaikum assalam, so I'm good.
Fine. Okay. हाँ, अच्छा। आपने कुछ देखा ऑर्गेनिक केमिस्ट्री का इरम अभी तक?
Introduction देखा।
वो इंट्रोडक्शन देखा, वो एक वीडियो जिसमें कुछ नहीं है। हाँ, हमने आपको प्लेलिस्ट जो भेजा था उसके बाद आपने इंट्रोडक्शन देखा। यस इरम।
Yes।
अरे तो आपको तो उसमें समझ में आ गया होगा ना कि लाइक इट इज जस्ट एन इंट्रोडक्शन जिन लोग ऑर्गेनिक केमिस्ट्री लाइक पहली बार पढ़ रहे हैं। बट आई होप यू लाइक द इंट्रोडक्शन एंड ऑल अबाउट आईयूपैक
Yes, sir.
नॉमेनक्लेचर।
It was good.
गुड। ओके, आई होप यू लाइक इट। बट अगेन, अगर आपको अच्छा लगा तो फिर और आगे देखना चाहिए था फिर उसको, है ना। वो इस तरह से बनाया इसी वजह से ताकि आप आगे देखें, लेकिन आपने यहीं तक अच्छा है, पढ़ाई नहीं करना है बस। ओके, चलो। बट प्लीज वॉच इट, ओके। कंप्लीट इट इन वन सेटिंग इरम, आईयूपैक नॉमेनक्लेचर। ओके इरम।
Yes।
चलिए, प्लीज राइट द टॉपिक। Molecular orbital theory. Now, this is the easiest theory of all the chemistry, and fundamentally it is very easy to understand. So don't think of any high level thing that you have learned in your school. Sigma hota, sigma star hota, pi hota, kya hota hai isme. There are a few very simple points, few rules, and those are very logical rules that we are going to learn, and from that we are going to make the molecular orbitals of different molecules. Okay, the very simple starting point of this theory is, please complete after me. In atoms, electrons are in the, कहाँ पे होते हैं electrons? Atomic orbitals. Yes or no? Please tell me, guys. They are in atomic orbitals. Is that correct?
Yes, sir.
Next. So plain and simple, chemists said that. They said that in molecules, electrons are in molecular orbital. They are where? They are in molecular orbital. Now we know atomic orbital SPDF. Those are the atomic orbitals. Those are the substance. Inside that we have the S orbitals, and there are the 3p orbitals, and we have the 5d orbitals and 14 f orbitals. Now, what are the molecular orbitals? Now this we have to now study what is molecular orbital. If you understand what is molecular orbital and how to make it from the atomic orbitals only, then it will be very clear. Now, molecular orbitals are formed. Please write molecular. This is also, I will refer to this as MOT. Okay, molecular orbitals. Molecular orbitals are formed by linear combination of atomic orbitals. Linear combination of atomic orbitals. इसको बोलते हैं LCA. ओके, लीनियर कॉम्बिनेशन ऑफ एटॉमिक ऑर्बिटल्स. जैसे 1 + 1 = 2 होता है ना, इस तरह का कॉम्बिनेशन है. ठीक है, इट इज एज सिंपल एज दैट. इट इज 1 + 1. अगर 2 + 2 है तो क्या मिलेगा आपको? यू विल गेट 4. ओके, इट इज दैट टाइप ऑफ combination, linear combination of atomic orbitals. Now we'll understand what is the linear combination of atomic orbitals. Please write the topic. Linear combination of atomic orbitals. This is LCAO. Now, combination of atomic orbitals give rise to molecular orbitals. Okay, give rise to molecular orbitals. Now, we have seen combination of atomic orbitals earlier also when we were learning the valence bond theory. Now, these atomic orbitals are of two different atoms. Okay, combination of atomic orbitals of two different atoms because we are talking about the bonding. Please also remember why it is different from hybridization. In hybridization, the atomic orbitals of a single atom, they used to mix with each other. But in this case, we have the atomic orbitals of two different atoms. We have atomic orbitals of two different atoms. Please remember this, guys, okay? In hybridization, we had the atomic orbitals of single atom. Here we are going to have two atoms, two different atoms. Now, if I'm going to take this very simplest case of the s orbital, which is having one electron like this, and there is also one more s orbital, which is having another electron. Okay, now when we are going to add both of these things, there two things can happen. Not two things can happen. Theoretically speaking, two things can happen. If you are a fan of valence bond theory, then overlapping can take place. Okay, so if you are going to overlap, okay, if you are going to, in VBT, what happens? In VBT, overlap happens and you get something like this. Please see, guys. Correct? Yes or no? Please tell me. We get something like this in the valence bond theory. Okay. But what happens in MOT? According to MOT, when both of these are going to overlap with each other, then they're going to form a new kind of orbitals. Now, this new orbital will be very different from the previous one. The new orbital will look something like this. Okay, the new orbital is going to look something like this. So here is the nucleus of one of the atoms. Here is the nucleus of the another atom, and both of these are mixing with each other. Now, what you can see, what is the difference here? This is overlap, and this is what? This is mixing. This is mixing. Now, when we have VBT in valence bond theory, please write. In valence bond theory, the atomic orbitals maintain its identity. ठीक है, आपको पता चल रहा है कि ये s orbital है, ये भी s orbital, right? But when you are going to see a molecular orbital, I mean, it is completely new type of orbital. We have not seen this type of shape anywhere else. But in MOT, what happens? In MOT, the atomic orbitals loses its identity. Okay, so this is if you are going to make egg and it is sunny side up, then you are going to get VBT. But if you are mixing it together and what you are doing, you are going to make an omelette, then it is kind of MOT. Okay, MOT se yaad rakhiye, it is what type of omelette where you are mixing everything. When you are mixing everything, it is MOT. And when the identity is still there, then it is what? Valence bond theory, and it is overlapping. Now, in this part of this class, we are going to focus more on the mixing part. Okay, we are totally going to focus on the mixing part. We are going to learn about the molecular orbital theory. Okay, I hope all of you guys have written this. If not, please tell me now. Is there anyone who is still writing? Anyone writing? Not. No one is writing. Okay, fine, great. Now, write some remarks. All of you understood till here? Yes or no? Please tell me. Wasiha, Tarif, Saurav.
Yes.
Yes.
Yes, sir.
Yes. Okay. What about you, Talha?
Yes, sir.
Yeah. Okay, great. Now, please write remarks. Molecular orbitals are formed by LCAO, linear combination of atomic orbitals of two atomic orbitals. Next point, number of, देखिए 1 + 1 is equal to 2, यानी कि अगर दो atomic orbitals अगर मिलेंगे तो you will get what? 2 molecular orbitals. Okay, you are going to get 2 molecular orbitals, and why that happens we will also see now. Number of molecular orbital formed is equal to number of atomic orbital getting mixed. Number of atomic orbital getting mixed. Okay. Now, all of you are not going to write what under this wavy line. No one will write anything after this wavy line. Okay. Now, please see, guys. If I'm going to make a s orbital like this, it can have a positive phase. Now, whenever we write something like this, please understand that this is a wave function. It is a wave only. It is a wave. A wave can be positive phase or negatively phased. This is the positive phase of the wave. This is the negative phase of the wave. Now, since S has only one lobe, it can either be positive. So if you are going to take, let us take the A case in which both the S orbital, they have positive phase. The B case would be one is having positive and the other is having negative. There are only two cases which is possible when the phase can be what? Either same or different. Right? These are the only two possibilities regarding the phase. या तो phase दोनों के same होंगे या तो phase दोनों के क्या हो सकते हैं? उल्टे हो सकते हैं. Right? They can be opposite. That means there are two combinations possible whenever two atomic orbitals are combining with each other. Okay. Now please remember there are many atoms, and many atoms are combining with like the pairs we have now. We have millions of pairs when there is a reaction happening. So in millions of pairs, some will be same phase, some will be oppositely phased. Okay, some will be oppositely phased. So what we can see, there are two types of combination that can happen. I will represent this as psi A. I will represent this as psi B. Okay, when it is positive. This will also be psi A because it is positive, but this one will be psi B with a negative sign because it is having negative phase. All of you are okay with the terminologies? Yes or no? Please tell me, guys. Is everyone okay with the terminology? Right?
Yes.
Can I move on? Okay. Okay. Now there are two combinations that can happen. We have just concluded psi A plus psi B. They can add with each other. Or second combination that can happen is psi A plus negative of psi B. Okay, negative of the psi B. Now, this means this is almost equal to psi A minus psi B. Psi A minus psi B. Now let us look at when we are going to have psi A plus psi B. What is the wave function and what is the wave, or what the waves are going to do? So for psi A, we have a positive phase like this. And for psi B, this is psi A. And for psi B also, we are going to have a positive phase. Okay, this is psi B. Now, when we are going to add it, we are going to get something like this. The amplitude will be added up. Okay. Now, another thing is that when we are going to have the another case in which you have, this is your psi A with a positive phase, plus we have psi B with a negative phase. This is going to give me no wave function, right? This is going to give me no wave function. Now, these are just the signs of the phases. These are just the signs of the phases. If you little bit remember about the probability of finding electron, probability of finding electron is given by what? It is given by psi square. All of you remember this? Yes or no? Please tell me. कुछ याद है psi square के बारे में? Significance of psi. Psi has no physical significance, but psi square gives the. You have done this, no? Why is everyone silent? The last class, yeah. See. Okay, psi is the amplitude of the wave associated with electron. Psi does not have any physical significance. Psi is directly proportional to the amplitude. Amplitude is directly proportional to the intensity. Psi square gives the probability of finding electron. per unit volume. Psi square has physical significance. Okay, psi does not have any physical. So now we are going to talk about psi square. यहाँ पे ना बहुत ही एक खूबसूरत चीज होती है. Please all of you take a notice. Please all of you take a notice. Before that, I want to ask you guys, if when we are going to talk about electrons, we are forming bond, and why we are talking about electrons, please listen to that. Okay, why we are talking about electrons? Whenever we are going to form a bond, why we talk about electrons of two different atoms? Whenever there is a bond, that means, let us suppose we have hydrogen atom and we have chlorine atom. What is the difference between hydrogen and chlorine? Can someone tell me? What is the most, like, what is the fundamental difference between hydrogen and chlorine? Devangi, attempt कीजिए आप. What is the fundamental difference between hydrogen and chlorine? Yes, Devangi. Oh, like, yeah, tell me, Devangi, what is the fundamental difference between hydrogen and chlorine, or any two atoms?
Sir, on basis of electronegativity.
No, not on the basis of electronegativity. More fundamental. देखिए, कौन सी ऐसी प्रॉपर्टी थी जो हम लोगों ने पढ़ा था जो किसी पे डिपेंड नहीं कर रहा था, वो अपने आप में ही एक प्रॉपर्टी थी. Think about it, because see, electronegativity depends on this, depends on that. So obviously it is depending on something. That means electronegativity is not fundamental. उससे भी fundamental कुछ हो सकता है. Iram, you tell me. If I look at the atoms of hydrogen and chlorine, what is the most fundamental difference I'm going to see? Iram, क्या ख्याल है आपका? Yes, Iram, tell me. Iram, are you not here? What happened?
Yeah.
What can you think of? Like, अगर जैसे electronegativity देवांगी ने बोला है ना, तो that is one of the differences. लेकिन उससे भी fundamental कुछ है. ठीक है. Iram, what can you think of? What is the difference between hydrogen and chlorine?
They are protons.
जोर से.
The number of protons.
जोर से भाई. Number of स्पष्ट नहीं दिया हमको.
The number of protons.
Yeah, that is very good. That is the most fundamental difference between any two elements, any two atoms. That is the number of protons. Okay, that is the number of protons. Okay, now what happens? आपके पास in reality, think in reality, in the atom of hydrogen ऐसे H बना हुआ नहीं है. You don't have any H written in the atom. What do we have? We have only one positive charge inside the nucleus. That is why it is hydrogen. Okay, now whenever you are having, let us suppose we are having two different hydrogen atoms. We have one hydrogen atom with a positive charge here. We have one hydrogen atom with a positive charge here. Both of these are going to attract each other or repel each other. Please tell me, guys. They will attract each other or repel? Positive and positive? Repel each other, right? Repel each other. Now, see the beauty of bond. तो ये दो न्यूक्लियाई जो है ऐसे बॉन्ड क्यों बना लेते हैं? Like why the hydrogen they are having a bond like this? That is only because if you are going to bring the electrons, okay, if you are going to bring the electrons in between, okay, that means we have electrons between the nuclei. अब क्या होगा? This positive charge will be attracted towards this side due to the presence of electron. Yes or no? Please tell me. Correct hai?
Yes, sir.
Yes or no, guys? This
Yes,
is
yes, sir.
the electron. Okay, this is the electron. And this positive charge will be this nucleus. This will be attracted towards the electron this side. Fundamentally, what we will be seeing that this nuclei is attracted towards this nuclei. Yes or no? Please tell me, guys.
Yes, sir. Yes, sir.
Now, I hope now you understand the role of electrons in the formation of bond and why the electrons are important. And where should the electron be present? They should be present. The electrons, they should be present between the nucleus. Okay, between the two nuclei of bonding atoms, the electron should be present. If the electron is not there, then there is no bond. If electron is present, we have a bond. Okay, so there should be electron between two atoms, between the nuclei of two atoms, for the formation of bond. That is why the electrons are very important. Okay, and that is why we are talking about psi, and now we are going to look at the psi square. Now, please see, when we had psi what? A plus B, psi A plus psi B. When we had psi A, plus psi b. Okay, and we are going to square it. Why we are going to square it? We are going to square it because psi square is going to give the probability of finding electron. This will give me psi a square plus psi b square plus 2 psi a psi b. Now this plus 2 psi a psi b is going to be the electrons probability between the nucleus. Okay, between the nucleus. Now psi square a तो हम लोगों को पता था होगा ही because we are squaring it. Psi square b we also knew that it is going to happen. But this another term 2 psi a psi b in which we are having one of the atomic orbitals from A, the another atomic orbital from B, and this is the part where the bonding happens. Now look what is going to happen if we are going to have psi a minus psi b. The second case जहाँ पे wave function जो था आपका the phase of that wave was 0, amplitude 0 हो चुका था. So we had psi square, psi a square plus psi b square minus 2 psi a psi b. Plus 2 psi a psi b means that electron will be present between the nucleus of A atom and B atom. Minus 2 a psi a psi b means that electron absent between the two nucleus. अब एक बात बताइए आप, we have positive charge and here we are going to have electrons. Okay, and we have another case in which we have positive charge and positive charge. This is not having any electrons. So I hope all of you understand that this is going to have attraction, this is going to have attraction, but both of these guys are going to repel each other. So I can for sure say the case where we are going to have psi a plus psi b, it is going to be more stable. It is going to be more stable. And in this case where we are having psi a minus psi b, this is going to be unstable. यहाँ तक clear है सबको? Yes or no? Please tell me, guys.
Yes, sir.
Yes, sir.
Yes, sir.
That means when we are having psi a plus psi b, then we are moving towards stability. When we are having psi a minus psi b, that means when we are having opposite phases. Okay, when we are this is okay, this is proton. Okay, this is not s orbital, this is proton. Okay, and this is going to be what? Unstable. Okay, अब energy की अगर terms में हम बात करें, please remember, like if you have this is more stable, that means it will have lower energy. If this is unstable, this is going to have higher energy. This is going to have what? This is going to have higher energy. ठीक है? यहाँ तक clear है सबको? Yes or no? Please tell me, guys. Clear है? Yes or no?
Yes, sir.
Lower energy and higher energy. Okay. So whenever anything is unstable, it is going to have higher energy. Now, when this is more stable, here what we can say, this will be your formation of bond will take place, and that is why we say that whatever molecular, यहाँ पे भी आपके पास, this is combining, right? This is a linear combination of atomic orbital. Okay, this is LCAO, but in this case, we are not forming a bond. That is why it is known as anti-bonding molecular orbital. Why the molecular orbital is formed? Because we are having linear combination in atomic orbital. Now, the linear combination of atomic orbital, what? It is not preferable, not feasible. Not feasible, say word nahi hoga, but I can say that it is not fruitful. The linear combination is not fruitful. It is not forming bond. That is why it is anti-bonding molecular orbital. Molecular orbital will be formed, but it will be anti-bonding. In this case, we will get bonding molecular orbital. In this case, what we are going to get? We are going to get bonding molecular orbital. That means when we are having same phase, then our combination is going to be fruitful. We are going to get a more stable system with lower energy and bonding molecular orbital. When it is going to have different phases, then it is going to be unstable. There will be repulsion, higher in energy, and anti-bonding molecular orbital will be formed. Now, is everything clear? Yes or no? Please tell me, guys.
Yes, sir. Clear.
Yes, all of you.
Yes, sir.
ठीक है, चलिए. Now, if you want to write something from here, from the explanation, if there is anything that you want to write, I will give you like 2-3 minutes. You can ask me to scroll up or down and then you can write. Okay, and I will just wait 2 minutes. आप एक बार देख लीजिए ऊपर से जहाँ तक हमने स्टार्ट किया था पढ़ाना. This is the wavy line. You have written everything from above, and after that I have started explanation. Okay, just let me know if you want to write anything. I will scroll up. Is everyone done? I hope everyone is done. Okay. Formation of molecular orbital. Formation of molecular orbital. When two atomic orbitals combine via linear combination, they combine via linear combination, then they do so by addition, and by subtraction. Okay, addition and subtraction. Subtraction of what? Of wave function of atomic orbitals. Okay, So whenever you are going to have addition, write the first case. Psi A as electric chemistry for two atoms A and B with a wave function psi A and psi B. Number one, psi A plus psi B is going to give you psi MO. That means the psi of or the wave function of the molecular orbital. Okay, the wave function of the molecular orbital. Now, second case will be, this is your bonding molecular orbital. Second case will be psi A minus psi B. It is going to give you psi star M. Okay, so we represent anti-bonding by psi star. Anti-bonding. Molecular orbital. When BMO is formed, electron is present. When BMO is formed, electron is present between the nuclei of two atoms. Hence, the system is stable. And BMO, bonding molecular orbital, has lower energy. Right, next. When ABMO is formed, electron is present क्या लिखे इसके लिए? Between का उल्टा क्या हो जाएगा? Either I can write electron is not present, लिख देते हैं ना, ज़्यादा बेहतर होगा. Electron is not present between the atoms, between the nuclei of atoms. This leads to repulsion, and ABMO has higher energy. एक बात याद रखिएगा, जब ABMO खाली होगा तब तो उसकी कोई एनर्जी नहीं है, लेकिन जैसे ही ABMO में इलेक्ट्रॉन आ जाएंगे, as soon as ABMO will get the electron, then the system will have higher energy. It will have higher energy and the system will be unstable. But if there is no electron, then you don't have to worry. ABMO is just present there, उसका कोई role नहीं है अभी. Okay, but as soon as you add electron, then the system will get unstable. All of you done yes or no, please tell me, guys.
Yes, sir.
Right, next. Now we are going to see the shapes of different molecular orbitals. Okay. Now please see mixing of, please write here. Mixing of different atomic orbitals to form molecular orbital. So the first mixing that we are going to see is 1s and 1s. Okay, so when 1s and 1s are going to mix with each other, then two things will happen. In the downside, I'm going to write the bonding molecular orbital. Okay, and here I'm going to write the ABMO, antibond, because lower in energy. जो नीचे BMO is will be lower in energy. Okay, BMO will be lower in energy. So this is your addition of the two atomic orbital. This is the subtraction of the two atomic orbital. So when both of these are going to be added, we will be getting something like this. Okay, this is one nuclei, this is the another nuclei. And here we are having the two nuclei, and in between you can see there is a, this is all electrons. Okay, whatever I have drawn like this now, this is all the electrons. Most of the electrons is present where? Most of the electron is present between the nuclei. But when subtraction is going to happen, we are going to get something like this. This is quite tough to draw. Something like this. Here we are going to have, this is like kind of kidney beans. The nuclei here, and same thing. But इसका हम इसको उल्टा कर देते हैं बस. Flip horizontally. Okay. So as you can see, both of these are nuclei and there is no electron in between. And that is why here you are going to have repulsion. Okay. And this will be what? Unstable. This will give you instability, and this is going to be higher in energy. Oh, sorry. This will be higher energy. Then we are going to have the addition. This is your BMO. This is your ABMO. There will be attraction here. This will be stable. This will be lower in energy. Okay. Now this BMO is called sigma 1s. That means we are forming sigma bond via what? Via the 1s orbital. Okay. If you are using 2s orbital, then it will be sigma 2s. Now in this case, this ABMO will be sigma star 1s. Okay. Star yaad hai? Because it is ABMO, we are writing star. And this sigma star has been formed via 1s orbital. All of you understood this? Yes or no? Please tell me.
Yes, sir.
Yes. Okay. Now, also one more thing you should know, that when we are having subtraction, this will be having a positive phase, this will be having a negative phase. Okay. Now we are going to talk about symmetry. If you look at this particular ABMO, this is what? This ABMO is what? It is unsymmetric. Okay. And this BMO, since it is addition, both of them will be having positive phase. And if I'm going to write like this, it is going to be what? This is going to be symmetric. एक और point लिख लीजिए इसमें. Sigma star 1s is what? It is unsymmetric or asymmetric, but sigma 1s, that is bonding molecular orbital, is symmetric in nature. All of you wrote this, yes or no? Please tell me, guys.
Yes, sir.
Okay. No. Okay, 1s and 1s can only combine with each other on the internuclear axis. Okay. They are going to combine in the internuclear axis only. That is this one axis. इन्हीं दोनों के बीच से ये लोग एक दूसरे के साथ combine कर सकते हैं. They can combine like this only. But when we are going to the PP mixing, please write the second one. Second case will be PP mixing. In this case, there can be, in this PP mixing, there can be two cases. We can have the p orbital mix like this, okay, via the internuclear axis. In one axis, internuclear axis का मतलब होता है the lobes and the nuclei, both of them are in the same axis, right? So this is one way in which they can mix. The other way is the nuclei and the lobes are on different axes, right? So they can also mix in this manner. So there are two cases when we are going to have PP mixing. So please see, all of you understood now? There can be two cases. Yes or no? Please tell me, guys.
Yes, sir.
Yes, sir.
Yeah, there will be two cases. So first case is right one, case one. When we are going to have atomic orbital combine or they mix on internuclear axis. अब ये इंटरन्यूक्लियर एक्सिस कुछ भी ले लीजिए आप, ठीक है ना, एक्स वाई जी, जनरली इट इज टेकन एज जी एंड सीईआरटी ने भी इसको जी मतलब जेड, ठीक है, सीईआरटी ने भी इसको जेड ही लिया हुआ है ना। आप लोग में से कितने लोगों ने इंटरन्यूक्लियर एक्सिस सुना है बताइए तो, लगता है आपको एनसीईआरटी में होगा, बट इट इज देयर इन एनसीईआरटी, ठीक है। एक सवाल भी है, they have said that z is internuclear axis and they have also asked one question, मान लीजिए अगर x इंटरन्यूक्लियर एक्सिस होगा तो इन दोनों के बीच में किस तरह के ऑर्बिटल्स बनेंगे, ओके, लेकिन वो वैलेंस बॉन्ड थ्योरी के मुताबिक उन्होंने पूछा हुआ है, ओके, बट स्टिल इंटरन्यूक्लियर एक्सिस, दिस वर्ड इज प्रेजेंट इन एनसीईआरटी, ओके। सो वी आर गोइंग टू मिक्स p orbitals. Let's have one p orbital like this. अब इसी को हम बस कॉपी पेस्ट करके I will rotate this thing horizontally. Yeah, horizontally. This is p orbital. This is another p orbital. Both of these are going to mix. Okay. Now addition है तो यानी कि they are mixing with the same. They are mixing in the same phase. And there can be a case in which they are not mixing in the same phase, right? So first of all, I am going to write here, and there this will be subtraction, open higher energy. Here we are going to do addition. Now, when we are going to do addition, both of these lobes, they will combine with each other and they are going to make something like this. Okay, this thing will be quite big. Okay, आपको दिख रहा है कि it is like one lobe and one lobe, both of these are mixing with each other. And now, then we have this another parts like this here. They will be small part here. And where is the nuclei? We have the nuclei here and here. As you can see, there is plenty of electrons between the nuclei. All of you can see that? Yes or no? Please tell me, guys.
Yes,
Yes,
sir.
sir.
All of you can see that, no? When both of these are mixing, they will be having same phase, positive phase लेके चलते हैं. So this whole thing will be positive phase. This will be negative phase. This will be negative phase. Okay. And again, also one more thing. This is going to be what? This is going to be sigma. Let us take, this is the 2p orbital and this is also 2p orbital. This will be sigma 2p. And when it is going to be subtracted, this lobe and this lobe, they are going to cancel each other out. There will be very small lobes remaining here. And large lobe will be this side. Very small lobe remaining here and the large lobe will be this side. I'll just increase the size of these things. Okay. So these will be very small. Okay. And this will have what? Sign बनाने के लिए हमको थोड़ा बड़ा करना पड़ेगा. But I hope all of you आप समझ जाइए ये दोनों काफी छोटे रहेंगे, ठीक है? These lobe will be very small. Also, you can see plenty of vacant space between the nuclei. Here is your nuclei and here is your nuclei. दोनों subtract कर दिया, cancel कर दिया एक दूसरे को. The subtraction had taken place. That means it will be what? This will be positive phase. This will be negative phased, right? This will be negative and this will be positive. Again, यही सारी चीजें हैं यहाँ पे भी. Attraction is there, right? Stability is there, and यहाँ पे unsymmetric repulsion and symmetric, right? Same things you are going to write for this case also. Just a second. इसको इधर थोड़ा खसका देते हैं. Let this whole thing be a bit here. And let me paste everything here. Okay, unsymmetric, repulsion, unstable, higher in energy, attraction, stable, lower in energy, and this what stable. And this will be known as, if this is 2p, 2p, this will be known as sigma star 2p. This is your ABMO, and this is my BMO. So when we are mixing on the internuclear axis, what we are forming? We are forming a sigma bond. Okay, we are forming a sigma bond. Then all of you, please tell me, guys. लिख लिया आप लोगों ने? नहीं लिखा अभी. Write it fast. Then we will look at the case 2. Done, guys? Yes or no? आगे बढ़े?
Done,
Is
sir.
anyone done now?
Yes, sir. Done.
Is anyone writing? No. ठीक. Right, next case 2. Yusuf, what happened? You are quite late.
Sir, I had some issues here.
Okay. अब please lecture देख लीजिएगा, ठीक है ना? It's very important.
All right, sir.
Okay. Write the case 2. Now, what is the case 2? In case 2, atomic orbitals combine above and below INA. Okay, the lobes of atomic orbitals, they are going to combine above and below. So we can make this is your internuclear axis. This will not be given, but we can understand that this is your one lobe. This is your another lobe. And then we are going to just flip it. Flip horizontal, no, vertical. Okay. So as you can see, the nucleus is in different axes, right? The nucleus you cannot combine. You can only combine the nucleus if you are going this way. If both the nuclei are going this way, then you'll not be able to combine, right? So this nucleus are in one axis and the lobes are in different axes. In this case, again, we are going to form two different types of molecular orbital, a bonding and an anti-bonding. So addition and subtraction se hoga. So in the case of addition, we are going to get, see, this lobe and this lobe, they will combine with each other. This is my internuclear axis here. It's my internuclear axis. They are going to combine with each other. They are going to form electron cloud like this. And they are going to form electron cloud like this. इसी को नीचे कर देते हैं ना. Okay, so the two electron clouds are here. Now let's suppose that this was positive, this was positive, negative, and this was negative. So this will become what? Positive. This will be negative. Now let us look at the, ये याद रहेगा नहीं रहेगा आप लोगों को पता नहीं, इसके लिए लिख दीजिए this is INA, internuclear axis. Now when we are going to draw the anti-bonding molecular orbital, then both of these are going to cancel each other. This negative part also is going to cancel each other because it is subtraction. Because it is going to subtraction. Now this is the nucleus. Some of the positive part has been taken away, so this lobes become, ठीक है, आधा हो गया लोब, ठीक है. We cannot draw it very properly, but I hope you can imagine it. That lobe has become half and it is getting away from the nucleus. And here also, in the second case also, this is my nucleus and my lobes are something like this. Okay, something like this. So both of them have subtracted each other with each other. But this is still positive. This will be what now? Negative. This is what? Negative, and this will be positive because subtractions happen and the phase will be changing. Now in this case, everything is same like before. Okay, all of these things are same except the symmetry. I will talk about the symmetry. Just wait a second. Okay, repulsion is there, unstable it is higher in energy. All of these things are true for the anti-bonding. But what about the symmetrical? What about the symmetry here? If you look at this particular, this will be, this will be pi orbital, pi 2p. This will be pi star 2p. This is your ABMO. This is your BMO. Okay, all of these things are simple. Now, obviously, if I look like this, then this is not symmetrical. See, if you look above the internuclear axis and below the internuclear axis, both of these phases are different. That is why it is what? It is not symmetric. It is unsymmetric. Okay, but if you look here, if you are going to look here like this particular negative sign is, if you're looking from here, please see from here, this has a negative sign this side, this has a negative sign this side, this has a positive sign this side, this has a positive sign this side. Okay, so it is completely symmetrical. It is completely symmetrical from the center here. It's completely symmetrical from the center here. But if you look at the center here, you go above, you get positive. You go below, you are going to get negative. But if you're looking from center here, you go from the, you go to the top right corner, negative. Top right का उल्टा क्या होगा? Top right का उल्टा क्या होगा? Top right का उल्टा होगा down and left. Down and left is also negative. So this is symmetrical, but this sigma 2p is unsymmetrical. This is symmetrical. Okay, please write these information. Symmetrical and unsymmetrical is a bit important. ठीक है, is a bit important. तो आप लोग को ध्यान रखिएगा symmetrical कौन सा है, unsymmetrical कौन सा है. All of you wrote this, yes or no, please tell me. All of you done? No. अच्छा, चलिए क्या आराम से लिखिए.
Done, sir.
Done.
तो बस हम लोग को ये yes, Mohammed Arif, tell me what happened.
Nothing, sir. I finished some.
Okay, finished. Okay, great. So we just needed to know about two different types of molecular orbital, the sigma and the pi. Okay, so we have seen sigma from the S and we have seen sigma from the P, and we have seen pi from the P. Pi can be only formed from P. Okay, but quick, can all of you please turn your mic on? Can all of you please turn your mic on? Please turn your mic on. ठीक है. What is the internuclear axis? No, keep your mic on ना, क्या दिक्कत है इसमें? देवांगी, इरम, फहद, तारीफ, अब्दुल्ला, तलहा, all of you. Turn your mic on. हाँ, कुछ बच्चे तो बिल्कुल, इरम, अब्दुल्ला and फहद. Yeah. What is the internuclear axis?
Z-axis.
Z-axis.
What is the internuclear axis?
Z-axis.
Z-axis is the internuclear axis. Okay, now very simply, you are going to tell me if I am going to combine 1s and 1s. क्या कर रहे हैं हम लोग? Linear combination atomic orbital. If I am going to combine 1s and 1s, how many molecular orbital I am going to get? Tell me, guys. How many molecular orbitals?
2.
You're going to get how many? All of you.
2.
How many molecular orbital?
2.
Sir, 2.
Very good. 2. What will be the names of this molecule? एक क्या होगा आपका? Bonding molecular orbital and the other will be?
Anti-bonding.
One will be anti-bonding. So for
Anti-bonding.
bonding molecular orbital, what do we write for 1s? What will be? Sigma बनेगा, pi बनेगा. Please keep your mic on and tell me now. You can see your notes and tell me. For bonding molecular orbital, it will be sigma or pi?
Sigma
For 1s
1s.
and 1s? Sigma 1s. And for ABMO?
Sigma star.
Sigma star
1s.
1s. Let's say, for example, we have 2s and 2s. Then if these are mixing, then what we are going to get? How many molecular orbitals are we going to get? Tell me. For 2s,
2.
2s, 2. There will be again 2 at these are what? Atomic orbitals. 2 atomic orbital will give me 2 molecular orbital. Tell me, guys. 2 atomic orbital will give me how many molecular orbitals?
2.
2.
2. One will be bonding, another will be anti-bonding. Please repeat this. One will be bonding. Repeat. One will be
Anti-bonding.
one will be bonding, another will be
Anti-bonding.
anti-bonding. So for now, when we are having SS mixing, it will be always sigma. So if you are going to write about BMO, it will be what? Sigma
2s.
2s.
2s. And for anti-bonding molecular orbital, it will be what?
Sigma star 2s.
Sigma star 2s. Okay. Now, when I ask you, if I am going to mix 2p and 2p, if I am going to mix what? Please tell me, guys, what I am mixing here?
2p and 2p.
If I'm going to mix 2p and 2p, then what are the molecular orbitals going to get formed? Tell me, guys. How many molecular orbitals will be formed? For 2p, 2p? If there are 2 atomic orbitals, then how many molecular orbitals?
2.
2. So how many molecular orbitals will be formed? Everyone, please answer me. How many molecular orbitals?
2.
2.
हाँ, but आप बोलिएगा सर 2p में ना 3 ऑर्बिटल होते हैं, right? We have 3. This is a subshell. आप क्या बोलिएगा? सर 2p is not an orbital. It is a subshell. 2p क्या है? Orbital है? नहीं. 2p is a subshell. It has 3 different orbitals. Now, whenever they are going to ask you what is going to happen if you are going to mix pp, then you will say which orbital of p? Px, py, or pz. And also, once you have told me what is p, if the px is going to mix or the py is going to mix or the pz is going to mix, also tell me what is the internuclear axis, because p has 2 different orbitals. If the orbitals are going to mix on the internuclear axis, then it is going to be sigma. But if it is not going to mix on internuclear axis, then it is going to be pi. So there are 2 things that we need to know whenever p is mixing. What is the p? Is it px? Is it py? Or is it pz? Then what else we need to know? We need to know the internuclear axis. Okay. Now, I have taken the internuclear axis as what? Tell me guys, what is the internuclear axis?
Z axis.
Z axis is the internuclear axis. Okay. Now, when I am going to mix 2pz and 2pz, then I am going to say, okay, fine. Now you have given me orbitals. So I will get a bonding molecular orbital. I will get an anti-bonding molecular orbital, right? I will get an anti-bonding molecular orbital. Now, we know that P has a tendency. P can, P may, P will sometimes make pi orbital. But now what it is going to make when you have the orbital of the internuclear axis, then it is going to be what? Sigma 2pz, and this will be what? Sigma star 2pz. All of you understood this? Because see, let's suppose this is my z axis. अगर ये आपका z axis है, मान लीजिए इसको, we can say ना, like ये आप x भी ले सकते हैं, y भी ले सकते हैं, z भी ले सकते हैं. हमने इसको क्या ले लिया? Z axis ले लिया. If this is my z axis, then the 2pz will be what? Like this, ना? सही है? Yes or no? Internuclear axis में ही lobes है. The nuclei and the lobes, all of them are on the axis and they are mixing with each other. So there is what? Head-on overlap, and that is why it is what? Sigma. Can all of you see this? Yes or no? Please tell me, guys. Can all of you see this?
Yes, sir.
Now, another thing, please see. If we are going to mix 2p, if we are going to mix 2px and 2px, okay, what we are going to mix? 2px of one orbital and 2px of another orbital. Then in this case, what is going to happen? This is an orbital. Yes or no? Please tell me, guys, all of you. Is this an orbital or subshell? 2px क्या है? Orbital है, subshell है?
Orbital.
Yes, Sahil? Can you please repeat that? I missed that.
Sir, is
I
it
missed
orbital?
It is orbital because it is 2px, है ना?
Yes, sir.
So it is going to give me how many molecular orbital? Tell me, guys. If we
Two.
have 2 atomic orbitals, it will give me. It will give me
2.
2. One will be. एक होगा. नाम क्या होगा? दो मिलेंगे ना, दोनों का नाम होता है ना
Bonding.
कुछ कुछ. हाँ, एक होगा bonding molecular orbital and the other will be
Anti-bonding.
Anti-bonding molecule.
anti-bonding molecular orbital. ठीक है. What is, now whenever you are having P, you will say what is my INA? What is my internuclear axis, guys? Tell me.
Sir, X. X.
X नहीं है भैया, Z है. क्या
Yes,
है?
Z, yes, yes, Z.
हाँ, Z है. ठीक है. X नहीं है, Z है. Okay. Internuclear axis is Z. Now you tell me. This is my Z axis. तो X क्या होता? Perpendicular to Z axis. So it will be like this. Yes or no? Please tell me, guys. Correct
Yes,
है?
sir.
है ना? Perpendicular. I hope आप लोग इतना कम से कम समझदार हो गए हैं कि ये सब PY है सर. है ना? ऐसा नहीं बोलिएगा ना आप लोग कि PY है ये. हम मेरा मर्जी भाई, किसी को कुछ भी बना दे. Right? All of these X, Y, and Z, these are. Oh God, my E is not working. Just a second. काम कर दे भाई. Okay. Again, it is not working. Just a second. Okay. Now, so this will be giving me sigma or pi. Tell me, guys, 2px. When the internuclear axis is Z, it will give me pi या sigma.
Pi.
Pi या sigma. जी, देवांगी.
Pi.
Pi मिलेगा. Pi 2px. And this will be pi star 2px. ठीक है? Similarly, if I'm going to have 2py and another 2py, then what is going to happen? Tell me, guys. Again, I'm going to get molecular orbitals. अरे बोलिए भाई, अभी तो आ गया होगा आप लोगों को. बोल क्यों नहीं रहे हैं? आवाज क्यों नहीं निकल रही? मेरी क्लास सूख गया यहाँ पे. बोलिए, चलिए. इरम,
Pi 2py.
अरे इरम बहुत एनर्जी सेव करी. देवांगी आप छोड़ दीजिए, आप रेस्ट कीजिए. इरम, टेल मी. How many molecular orbitals will we get? Yes,
Two.
Iram.
2.
Very good. What are those molecular orbitals? क्या बोलते हैं उसको? एक होता है
Bonding molecular orbital and anti-bonding molecular.
BMO and ABMO. What is my INA? P mix हो रहा है तो
Z.
INA क्या है? Z. अगर Z INA है, so I will be getting pi या sigma.
Pi.
Pi 2py and pi star
2py.
All of you understood this? Yes or no? Please tell me, guys.
Yes, sir.
Yes, sir.
अब देखिए एक बात मान लीजिए, प्लीज लिसन, लेट्स सपोज आई हैव 2px and 2py. अगर ये दोनों मिक्स होंगे तो क्या होगा? If they are going to mix, this is my what? This is my x axis, this is my y axis, right? So 2px will be something like this, 2py will be something like this. दोनों एक दूसरे से मिक्स ही नहीं होंगे. No orbital is mixing. No orbital is mixing. दिख रहा है आप लोगों को? Yes or no? Please tell me, guys. This is my x and this is my y. है ना? तो कोई ऑर्बिटल एक दूसरे से मिक्स ही नहीं हो रहा. So this type of mixing will not lead to the formation of molecular orbital, and these are not the cases in which mixing can happen. Okay, so please write conditions for combination of atomic orbital. Please write conditions for combination of atomic orbital. Number 1, combining AO should have same or slightly different energies. ठीक है, ऐसा नहीं कि एक एनर्जी बहुत कम है, एक एनर्जी बहुत ज्यादा, तो दोनों एक दूसरे के साथ मिक्स ही नहीं हो पाएंगे. ओके, दे शुड हैव सिमिलर काइंड ऑफ एनर्जीज. जैसे 1s दोनों का सिमिलर एनर्जी है, 1s 2s भी हो सकता है मिक्स, थोड़ा सा सिमिलर एनर्जी है, राइट? लेकिन it will be very difficult if you are going to combine 1s and 7s or 8s. Okay, now right, next, combining AO should have same symmetry. They should have same symmetry. Third, the combining AO should overlap to maximum extent. They should overlap to maximum extent. All of you wrote these 3 points, yes or no? Please tell me, guys.
Yes, sir.
सबने लिख लिया? Just a second. अभी हम लोगों ने किया है, ठीक है, यही सवाल देखा. 2s मिक्स किया था हम लोगों ने, प्लस में है तो बॉन्डिंग मिलेगा, है ना? आई एम जस्ट डूइंग द फर्स्ट वन. 2s प्लस 2s क्या देगा बताइए तो जरा, सिग्मा देगा या फिर पाई देगा? टेल मी, सिग्मा या पाई? ऐसा तो क्या देगा, सिग्मा या पाई? लाउडली. यस सौरभ, पाई देगा? अरे यार, अभी हमने पढ़ाया इतना. अरे पाई फिर क्यों बोल रहे हैं? पाई बोलिएगा आप तो फिर तो मेरा पूरा विश्वास उठ जाएगा ना. हाँ, पाई कैसे बोल सकते हैं आप? क्या देगा? सिग्मा देगा. सिग्मा 2s. ठीक है, और अगर एंटी बॉन्डिंग के लिए स्टार लगा दीजिएगा। आई होप आप लोग सही कीजिएगा। प्लीज राइट दिस डाउन। सौरभ, यू विल सेंड द आंसर टू दिस नंबर। सौरभ, आपके पास व्हाट्सएप है?
यस सर।
हाँ, तो इसको प्लीज ऐड कर लीजिए।
ओके सर।
Guys, you guys can tell me anything. Suppose I decide to sell this number. Okay, this is my number. Suppose I decide to sell this particular like phone number. Then like, will it be like very worthy? What do you guys think? Tarif, Saurav? Because it has ending with of 007. Do you think it will be expensive? Should I sell this number?
No, sir.
You want, sir, but it's best to keep it.
Okay, it's nice to keep it.
Yeah.
You know, I got this number when I was in 9th standard. So since 9th class, I'm having the same number. 9th or 10th, I will say, like the end of 9th. Since then, I have the same number. हाँ, अच्छा, कुछ बच्चे ये ना सोचने लगे कि सर पता नहीं, शायद आप लोगों को तो फोन मिल जाता होगा। देवांगी, आपको कब फोन मिला? यू हैव योर ओन फोन नाउ, देवांगी?
No, sir.
यू डोंट? अच्छा, हाँ, तो फिर ये मत सोचिए आप लोग कि सर आपके पेरेंट्स तो बड़ा ही लीनियंट थे, बड़ा ही मॉडर्न थे, 9th क्लास में ही दे दिया सर आपको फोन। पहली बात, आई वॉज अवे फ्रॉम होम, ओके, तो आई यूज टू लिव kind of alone. Like I used to live with one of my relatives. He was doing MBA and I was in 9th standard, and it was Jamia Millia Islamia in Delhi. Okay, so I was away from parents. That is why I got a phone. इसलिए नहीं कि बहुत छूट मिली हुई थी घर में। और किस किस के पास फोन नहीं है? सौरभ, आपके पास है फोन अपना?
यस सर।
आपके पास है। ये मिडिल ईस्ट वालों के पास तो होगा ही, है ना? इरम, आपके पास अपना फोन होगा, राइट?
Obviously.
ऑब्वियसली, देखे, ऑब्वियसली मतलब एंटाइटलमेंट की ना हद होती है। इट्स लाइक ऑब्वियसली होना चाहिए सर। व्हाट अबाउट यूसुफ, आपके पास अपना फोन है?
यस सर।
यस। तलहा?
यस सर।
ऑल ऑफ यू। फहद, आपके पास भी अपना फोन है, राइट? आई थिंक सो। फहद तो भाग ही गए फोन का नाम सुन के। Yeah, Saurabh, I received your message. I will just add you up. Okay, you will just send the answers. Okay, please send the answers. How was your half yearly, by the way, Saurabh?
Sir, not good.
It was not good. Which subject was the worst?
All of
All of them.
yes.
कोई नहीं, but like you will bounce back. घबराने की जरूरत नहीं है।
Okay, sir.
आई थिंक लाइक किसी भी स्टूडेंट के लिए 11th आसान नहीं रहता है। ओके, एंड आई थिंक बाकी सबका भी यही एक्सपीरियंस रहा होगा। आई थिंक एटलीस्ट आई रिमेम्बर फॉर इरम एंड देवांगी, राइट इरम? इनिशियल डेज वर वेरी टफ, यस और नो?
Yes, sir.
अब ठीक है सब, संभला हुआ है?
हाँ, अभी ठीक है।
अभी ठीक है सब। देवांगी, व्हाट अबाउट यू?
Yes, sir.
हाँ, एक तो चीज है लाइक यू विल स्टार्ट टू लर्न वेरी क्विकली थिंग्स। सबसे पहले कि अपने आप को मैनेज कैसे करना है, दैट यू विल अंडरस्टैंड वेरी इफेक्टिवली इन 11th एंड 12th स्टैंडर्ड। भले ही अगर कोई सब्जेक्ट आपके काम ना आए, है ना, आपको लग रहा होगा सर हमको तो सर प्रोग्रामिंग करना है क्या, अच्छा क्या है आपका स्ट्रीम सौरभ? मैथ्स है, बायो है, या फिर दोनों है?
Some maths and CS, computer science.
कंप्यूटर साइंस। आगे आपको यहाँ यू वांट टू डू कंप्यूटर साइंस या कुछ और इरादा है ना? तो फिर आपको तो लग रहा होगा कि ये सर हम क्या सीख रहे हैं सर, ये सिग्मा 2s, है ना, कहाँ काम आएगा हमको जब हम कोडिंग कर रहे होंगे तो क्या काम आएगा मेरे? दैट इज ट्रू, दैट्स फॉर श्योर ट्रू कि लाइक दिस इज नॉट गोइंग टू हेल्प यू इन प्रोग्रामिंग एट ऑल, बट 11th 12th का जो फेज है ना, दैट इज गोइंग टू टीच यू थिंग्स जो कि पढ़ाई के अलावा, लाइक हाउ टू सेट अप टाइम टेबल, हाउ टू रिमेम्बर थिंग्स फॉर अ लॉन्ग ड्यूरेशन ऑफ टाइम, how to set up a revision protocol, okay, how to write answers and get marks from those answers, है ना? So these things you will understand, that will be lifelong. एक चीज है, there is like please search in YouTube, okay? ये चीज पढ़ाई नहीं जाती है, learning how to learn, ठीक है? मेरे पास टाइम रहता तो हम ही पढ़ा देते आप लोगों को कि you should learn how to learn anything. दिस इज वेरी इंपॉर्टेंट स्किल जो आपको हमेशा याद काम देगा। अरे नहीं 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 नहीं, देखिए देवांगी आपने गलती कर दी, अगर प्लस है तो सिर्फ और सिर्फ बॉन्डिंग बनेगा ना, एंटी बॉन्डिंग थोड़ी ना बनेगा। एडिशन हो जा रहा है ना यहाँ पे। अगर हम ये लिखते हैं ना 2s एंड 2s अगर मिक्स करेंगे तब आप बोलते हैं हाँ, अगर 2s एंड 2s मिक्स करेंगे तो दो बन सकते हैं, बट इफ आई एम राइटिंग 2s प्लस 2s तो एक ही ऑप्शन है आपके पास, राइट देवांगी? यस और नो, प्लीज टेल मी।
Yes, sir, got it.
गॉट इट ना, अंडरस्टैंड द डिफरेंस यार। नहीं नहीं तारीफ, यू शुड हैव लाइक व्हेन इट इज सब्ट्रैक्शन इट विल बी एंटी बॉन्डिंग ना तारीफ। तारीफ यू हैव माय नंबर,
Yes, sir.
यू डोंट हैव माय नंबर?
Yes, sir. Yes, sir. Yes, sir. I
You
have.
have my number ना? हाँ, also just remember when it is subtraction है, that means it will be what, anti bonding, जहाँ पे हम स्टार लगा देते हैं, right?
Yes, sir.
Okay, we add star for those things. Please send the answers once you are done. Guys, send the answers, इतना टाइम नहीं लगना चाहिए, they've already done these type of things. Iram, yes, Iram, correct, very good, correct, everything is correct. By the way, Iram, how is Aisha? उसकी पढ़ाई ठीक चल रही है?
हाँ सर चलिए।
Guys, I'm waiting. सौरभ, आप सिर्फ ना फोटो भेज दीजिए, लिखने की जरूरत नहीं है, ठीक है ना? I hope you have done it in your notebook and you can just click a photo and send me. Waiting for Talha, Yusuf and Tarif. Please send an answer fast.
Sir, can I send in chat?
चैट में भेजिएगा, भेज दीजिए, चैट में बहुत टाइम लगेगा लेकिन. Okay, Saurabh, looking at your answer. Handwriting आपकी. Okay, fine. Ignoring the handwriting, 2px minus 2px will be correct. 2pz will be. Oh, sorry. एक second. Iram. Second is 2px. Iram. Second one is 2px. इरम, आपने 2pz
हाँ
लिख दिया है.
एक मिनट सर।
आंसर सही लिखा है आपने, ठीक है, बट दैट इज डिफरेंट. सेकंड सौरभ, दैट इज नॉट करेक्ट. Talha, it's fine. Second one. Saurabh, can you please turn your mic on?
Yes, sir.
Yeah, tell me what is the internuclear axis?
Sir.
Z is the, it is given in the question, right? Z is the internuclear axis. Now, your x, if let's, for example, let us say this is your Z axis. So x will be like this, na? Perpendicular to the Z axis, yes or no?
Yes.
So this will make sigma or pi? Yes, Saurabh? Tell me. If they are going to mix, then they are going to make like what, sigma or pi? जोर से बोलिए, I cannot hear you. Tala, third is correct. Yes, Saurabh? Saurabh, please यार, आप ना माइक ठीक करके आइएगा अगले क्लास में, okay, Saurabh?
Okay.
I'm just letting you know that when they are going to mix, I hope you can see that if this is my internuclear axis Z, then this is going to give you what? Pi. Okay.
Yes.
This is going to give you pi, and it will be what? Pi star, because it is minus. Okay, see, for the first one it will be sigma 2s. Second one it is going to be pi star 2px. For the third one it is going to be sigma 2pz, because internuclear axis is same. Okay, the axis of orbital and the axis of the internuclear axis, if they are different, it will be pi, and if they are same, it is going to be sigma. For the fourth one, it is going to be sigma star 1s. ये सही है आपका. Fifth one 2py, तो pi 2py होगा. Okay. चलिए, that is fine, all of you. Please note it down if it was wrong. Right, another question. Okay, please see here, guys. Don't write anything, please see here. What they are asking, they are saying, if Z axis is the internuclear axis, which of the following combination are not allowed? Which of the following combination are not allowed? देखिए, when it is what? When it is what? S and S, it will be always allowed. It will be always allowed no matter what the SS is always allowed. Okay, no matter what the INA is. Okay, first thing is that. Second thing, when you are having S and P, one S and P, see, so S and P of INA is allowed. ठीक है, मान लीजिए आपके पास क्या है, you have the Z axis, then S and PZ is allowed. Why? S यहाँ पे आपका, this is your internuclear axis, PZ will be like this. So this will be allowed, right? If you have positive and positive, there can be some bonding molecular orbital or anti-bonding molecular orbital. But here we are having a case in which we have S and we are having 2px. S will be like this. Okay, this is my internuclear axis, and px is going to be like this. So it is going to give you zero overlap. Okay, so half of the positive and half of the negative phase are going to overlap with each other. This is not possible. It will not be allowed. What is allowed? S and the P of internuclear axis is allowed. Next thing. P axis and P axis. If the axes are same for P orbital, it is allowed. ठीक है? जैसे 2py, it will be allowed. Now 2px and 2pz will not be allowed. P orbital of different axes are not allowed. Why? Because symmetry same नहीं है ना दोनों की. एक आपका है क्या 2px, एक यहाँ पे ऐसे होगा और एक होगा 2pz. दोनों की symmetry बिल्कुल अलग है, right? Both of these are having different symmetries. If you look at this particular nuclei, you're having positive here, you're having negative here. But if you look at here, this nuclei, it is not having anything here, not having anything here. Okay. So the symmetry is not same. That is why what will happen? The p orbital of different axes are not allowed. So what is not allowed? 1s and 2px will not be allowed because s and p of internuclear axis is only allowed. 2py will be allowed. This will not be allowed. 2pz, p axis, it is allowed. 2s and 2pz, it will be allowed because it is having s and the p of internuclear axis. This is also allowed. 2px and 2py will not be allowed. So these are the three will not be allowed. Okay. All of you understood this? Yes or no? Please tell me, guys.
Yes, sir.
Sir.
Write this down and write it fast. All of you done? Yes or no? Please tell me. Is everyone done? Yes or no?
Yes, sir.
Done. Right, next. Molecular orbital diagrams. Okay, molecular orbital diagrams. Now, I will give you a basic idea of how a molecular orbital diagram looks like and what are the different things here. Okay, molecular orbital diagram, it is kind of like आप उसको इसमें एक axis भी होता है. Okay, there is also one axis. Please write. The y-axis of this is MOD. Molecular orbital diagram represents the total energy. Okay, the total energy of orbitals. Orbitals की energy बताता है y-axis. Right, next. The combining AOs, atomic orbital, are arranged on the far left and far right and far right of diagram. ठीक है. Third, the MO formed are arranged in between the atomic orbitals. MO का मतलब all the molecular orbitals. Okay, all the molecular orbitals. ठीक है. चलिए हम आप लोग को एक चीज दिखाएंगे, फिर आप लोग बताइएगा. I will ask you guys different things. All of you wrote this point, yes or no? Please tell me, guys.
Yes, sir.
So,
So, देखिए, a typical MO diagram, no, not a typical, but a simple MO diagram is going to look like this. ठीक है. शायद आप लोगों ने देखा हो पहले. अब ये बताइए, what is this? Atomic orbital or molecular orbital? Tell me, guys, what is this? Atomic orbital or molecular orbital?
Atomic orbital.
Iram, Tarif, Saurav, Talha, tell me.
sir, atomic orbit.
है ना? इरम, आपको दिख रहा है एटॉमिक ऑर्बिटल क्यों होगा? यस इरम, टेल मी.
नहीं
नहीं दिख रहा है. ये बताइए क्या लिखा हुआ है यहाँ पे?
1s.
तो 1s तो एटॉमिक ऑर्बिटल का ही हो सकता है ना? अच्छा, और अगर हम इस डायग्राम को देखें, दिस इज योर लेफ्ट, दिस इज योर राइट, दिस इज योर मिडल, है ना? वी रोट ना, combining atomic orbitals are arranged on the far left and far right of the diagram. ठीक है, देखिए, you have 1s here and another 1s here. Can you see now, Iram? Yes or no?
Yeah.
Okay. Now, what will be this? Atomic या फिर molecular orbital?
Sir, molecular.
Molecular.
And this one will be?
Molecular.
Okay. Now, who will tell me why is sigma star above and why is sigma 1s below?
Because sigma star has high energy.
है ना? अभी हम लोगों ने क्या देखा? हम लोगों ने बोला कि y axis is going to give you energy of the orbitals. ठीक है, चाहे वो molecular orbital हो, चाहे वो atomic orbital हो. Okay, that means as you can see, sigma star 1s is higher in energy than the 1s orbital. ठीक है, and sigma star is higher in energy than 1s and sigma 1s is lower in energy. That means जो BMO है आपका, that is lower in energy and the ABMO is higher in energy. लेकिन किससे? इस atomic orbital से. All of you understood this? Yes or no? Please tell me, guys.
Sir, understood.
Yes, Iram,
Yes.
Devangi, Tarif, Saurav,
Yes.
Talha. Saurav, you understood this? Yes or no? Yes. Saurav, you understood this? Yes or no?
Yes, sir.
Yes ना? पक्की बात? Yes, Saurav?
Sir?
अच्छा, आपको हिंदी नहीं, you don't understand Hindi at all?
No, I do.
है ना? हम बोल रहे पक्की बात, आपको समझ में आ गया ना?
Oh, yes, yes.
Yes ना? Okay. Fine. Now, we'll look at a very simple. आप लोग यहाँ पे अभी हम तो ऐसे ही बना दे रहे हैं, लेकिन I will write the steps on how to draw. ये तो बस एक है कि molecular orbital diagram को आपको देखना कैसे. Now, how to form this molecular orbital diagram, that is another thing. Whenever you are going to form a molecular orbital diagram, you are going to form for the molecule. We'll look at the very simplest molecule. Number 1, formation of H2 molecule. ठीक है? बड़ी आराम से देखेंगे. First of all, how many atoms do we have? Tell me, guys. How many atoms do we have in H2?
2.
2 atoms. ठीक है. Now, how many valence electron do we have in each? In each atom, how many valence electron? Tell me. How many valence electron? हाइड्रोजन में कितने valence electron होते हैं? देवांगी, इरम, सौरभ,
1.
तलहा, तारी.
1.
1. Very good. Okay. Now, the orbital in which valence electron is present. बताइए कौन सा ऑर्बिटल में होते हैं इलेक्ट्रॉन हाइड्रोजन के? जल्दी. Which orbital?
1s.
1s. Very good. ठीक है. अब देखिए, we have 2 atoms, that means we'll have 1s orbital, and how many 1s orbital? We'll have 2 1s orbital. ठीक है. So we'll draw a 1s orbital like this here. Okay, in the far left and then in the far right. Okay. Now this is my 1s. This is my 1s. That means both of these are of what? These are atomic orbital. This is also atomic orbital. Okay, this atomic orbital belongs to hydrogen. This atomic orbital also belongs to hydrogen. Now, when they are going to mix, they are going to form molecular orbital. They are going to form what? They are going to form molecular orbital. एक ऊपर होगा एनर्जी में और एक आपका एनर्जी में. One diagram and then this is the second. One will be lower in energy. सही है guys? Okay. Now, then you are going to, आप इस तरह से dotted lines इसको represent कर सकते हैं. Sorry for that. I'll just take it like this. ओके, कुछ इस तरह से बना दीजिए आप. ठीक है ना. ये आपका बन गया. दिस इज योर MO. और MO किसका होता है? H2 का होगा. मॉलिक्यूलर ऑर्बिटल किसका होगा? H2 का होगा. दिस विल बी योर सिग्मा 1s. दिस विल बी योर सिग्मा स्टार 1s. नाउ दिस 1s ऑर्बिटल विल हैव 1 इलेक्ट्रॉन. सही है गाइस? यस और नो? प्लीज टेल मी.
Yes, sir.
करेक्ट? यस और नो? दिस विल
Yes,
हैव.
sir.
एंड द अनदर 1s विल हैव हाउ मेनी इलेक्ट्रॉन्स? अगले वाले के पास कितना होगा?
1.
टेल मी गाइस.
1.
That will also have same spin में. ठीक है, दोनों के पास 1s ऑर्बिटल है. ठीक है. Now when they are going to mix this molecule of hydrogen H2 में आपके पास कितने इलेक्ट्रॉन हो जाएंगे? 2 इलेक्ट्रॉन. और दोनों, टेल मी, इलेक्ट्रॉन को क्या चाहिए? वो ज्यादा एनर्जी में रहना चाहेगा या फिर कम एनर्जी में? तो वांट टू बी इन हायर एनर्जी और लोअर एनर्जी? इलेक्ट्रॉन्स will want to be in higher energy or lower energy, which is more stable?
Lower.
लोअर एनर्जी. ठीक है. तो ये दोनों इलेक्ट्रॉन H2 के सिग्मा 1s में होंगे. यहाँ पे 2 इलेक्ट्रॉन. Each orbital can hold how many electrons? 2 electrons, right?
Two.
No matter whether it
Yes,
is
sir.
atomic orbital or molecular orbital, all of the orbitals they have a capacity of holding only 2 electrons. ठीक है. Please don't say कि सर P में 6 होते हैं. P is a subshell. P is not an orbital, it is a subshell. Each orbital has a capacity of 2 electrons, whether it is atomic or it is molecular. When we are having molecular orbital, then 1s and 1s, they are going to combine with each other. They are going to form sigma star 1s and sigma 1s. Now the electrons, they have a option. They can reside on sigma star and they can reside on sigma 1s. So obviously they are going to choose sigma 1s because it is lower energy. Is this clear? Yes or no? Please tell me, guys. Devangi, Iram, Tarif, Saurav, Talha. Is this clear?
Yes, sir.
Yes, sir.
Yes. यहाँ तक इसको बनाइए, फिर आगे की बातें आगे करेंगे. अच्छा, one thing guys, this Thursday I will not be taking your class. Okay. So rather you are going to have a test on chemical bonding. Topics will be like chemical bonding and periodic properties and chapter 3. Okay, chapter 3, complete chapter, chemical bonding के हम टॉपिक्स बता दे रहे हैं। दिस इज फुल केमिकल बॉन्डिंग के लिए प्लीज यू राइट दिस टाइम, राइट ऑल ऑफ दीज थिंग्स। ओके, केमिकल बॉन्डिंग के लिए टाइप्स ऐसे मत लिखिए, आयोनिक बॉन्ड, रादर बेटर थिंग इज till VSEPR theory. Okay, this is from notes. नोट्स में देखिएगा VSEPR थ्योरी कहाँ तक है, ठीक है, वहां तक आपको करना है। दैट मीन्स हम डेट बता दे रहे हैं आप लोगों को। थर्सडे, एक सेकेंड, या थर्सडे विल बी देयर बिकॉज बॉन्ड पैरामीटर सारे उसी चीज में आ जाएंगे। एंड दिस इज व्हाट, या सो 13th of October, यहाँ तक के जितने भी जहाँ जो भी क्लासेस कराए हैं ना हमने केमिकल बॉन्डिंग में, ऑल ऑफ दीज थिंग्स, एंड देन चैप्टर 3 that will be full chapter. Total marks will be 25 marks. We'll have 1 hour, a 1 hour time. There will be 1 marks question, MCQs, उसमें assertion reason वाले सवाल भी होंगे, 2 marks question, 3 marks question, and there will be 1 5 marks question also. Okay, please note this down, all of you, और इसको भी बना लीजिए।
So,
Yeah, tell me. Somebody said
yeah, I won't be able to attend this test.
why? What happened? Yes, Iram.
So, तो मैं कहीं जा रही हूँ।
दावत है कहीं? कहाँ जा रहे हैं आप?
नहीं सर, फंक्शन है
फंक्शन है? अच्छा,
स्कूल का।
फीफा है क्या? फीफा का फंक्शन है?
नहीं स्कूल का।
अच्छा, स्कूल का फंक्शन है। अच्छा, ठीक है। चलिए, आपका ऐसे भी टेस्ट हो चुका है ना इसका, तो
हाँ,
स्कूल में एटलीस्ट, है ना?
हाँ।
स्कूल में एटलीस्ट हो चुका है। बट दिस इज स्पेशली इंपॉर्टेंट फॉर सौरभ, तलहा, तारीफ। ओके, जो लोग इन चैप्टर्स में हमारे साथ नहीं थे। देवांगी, आप तो थी ना चैप्टर 3 में?
यस सर।
तो आप टेस्ट तो दीजिएगा प्लीज, ठीक है, बट इट इज मोर इम्पोर्टेंट फॉर दोज हु हैव नॉट डन द क्लासेस विद मी। ओके, सेम टाइम, क्लास के टाइम में आपका टेस्ट होगा 1 घंटे का। ओके, ऑल्सो आई विल नॉट बी कंडक्टिंग द टेस्ट, ठीक है, हम नहीं रहेंगे। एक्चुअली आई एम ट्रैवलिंग, दैट इज व्हाई यू आर नॉट हैविंग द क्लास, यू आर हैविंग अ टेस्ट। एंड अनदर थिंग इज, आप लोग तैयारी ऐसा करके आइएगा ना कि आपको कोई सवाल नहीं पूछना पड़े, डाउट नहीं पूछना पड़े क्वेश्चन में। ओके, तो सालिम सब रहेंगे नहीं वहां पे समझाने के लिए कि इस सवाल में ये पूछा है या फिर ये पूछा है, अच्छे से पढ़िएगा। ओके, ऑल्सो बट आई विल बी अवेलेबल फॉर any doubt if you have. WhatsApp में you please send me any doubt. Saurabh, you have my number now. I think Tarif and Talha, both of you have my number. देवांगी पास तो है ही, इरम का तो टेस्ट नहीं दे रही है। तारीफ, you have my number, right?
Yes, sir. Sir, and that answer can I send after some time? That for some problem is there.
फिर अगर आप आंसर लाइक इफ यू डोंट सेंड इट इन लाइक 1 hour, देन फिर हम उसको थोड़ा सा वैसे चेक करेंगे कि शायद आपने चीटिंग किया हो। ओके, तारीफ,
Yes, sir. Yes, sir.
I will take special care. If I see anything dodgy there, then I will be just putting the marks there. Okay, chalo. Thank you guys. I hope you have written everything. Okay, we'll meet
Sir.
on, yeah, Devangi.
सर आपने कहा था कि अगर उसमें ABMO में एक भी इलेक्ट्रॉन नहीं होगा तो फिर वो अनस्टेबल नहीं होगा।
हाँ, इसीलिए तो H2 मॉलिक्यूल जो है, अगर हम इलेक्ट्रॉन डाल दें तो अनस्टेबल हो जाएगा ना, इस वजह से इलेक्ट्रॉन नहीं डाला हमने देवांगी।
सर तो फिर उसको हाई एनर्जी में क्यों दिखाया है?
उसको हाई, वो उसकी एनर्जी तो जैसे ही आप इलेक्ट्रॉन डालिएगा हाई हो जाएगा, तो फिर मतलब हम लोग तो एक ही चीज ड्रॉ कर सकते हैं ना देवांगी, मतलब आप समझ रही हैं बात को?
सर मतलब वैसे वो एग्जिस्ट नहीं करता ना।
हाँ, ऐसे मतलब कोई, जैसे मान लीजिए अगर हम आपसे पूछें एस ऑर्बिटल की एनर्जी ज्यादा है, पी की ज्यादा है, या डी की ज्यादा है, जो सबसे ज्यादा दूर होता है उसकी एनर्जी सबसे ज्यादा होती है, राइट?
यस सर।
है ना? लेकिन डी अगर खाली है तब उसकी कोई एनर्जी नहीं। डी में अगर इलेक्ट्रॉन आएगा ना, जैसे जैसे इलेक्ट्रॉन न्यूक्लियस से दूर चला जाएगा तो अट्रैक्शन कम होता जाएगा, अट्रैक्शन कम होता जाएगा तो एनर्जी उसकी बढ़ते जाएगी, ठीक है? यानी कि डी में जब जब d ऑर्बिटल में इलेक्ट्रॉन आता है तब उस इलेक्ट्रॉन की एनर्जी हाई हो जाती है। वही इलेक्ट्रॉन जब p में रहता है तब उसकी एनर्जी कम रहती है। जब वही इलेक्ट्रॉन s में रहता है देन इट इज इवन लोअर। गॉट इट देवांगी?
यस सर।
है ना? इसी अब देखिए इस वजह से ना सिग्मा स्टार 1s की एनर्जी ज्यादा है का मतलब है कि अगर उसमें इलेक्ट्रॉन जाएगा तब ज्यादा हो जाएगी एनर्जी, तो सिस्टम अनस्टेबल हो जाएगा। ठीक है, तो सिस्टम अभी स्टेबल है। ओके, सिस्टम इज स्टेबल। और जब
यस
तक
सर।
इलेक्ट्रॉन नहीं है ना ऑर्बिटल में, किसी भी ऑर्बिटल में, तब तक उस ऑर्बिटल का कोई काम नहीं है। यू कैन इग्नोर द